my YouTube viewers. In this particular video, what we're going to be discussing is estimation and descriptive statistics. So in estimation and descriptive statistics, they cover estimating population parameters such as mean, variance, and proportion to summarize and describe data. And so what we're going to do is we're going to go over a program written in Python to illustrate this. So the first thing that we want to do is we want to import two libraries. The first library is import NumPy as NP, which is your numeric library, and the second library is import matplotlib.pyplot as PLT, which is your visualization library. And then what we're going to do is we're going to generate sample data such as heights. So the first thing we want to do is we want to set our seed. And the reason why you set your seed is so that every time you run the program, it will run with the same initial values. So you type np.random.seed and you can type whatever you like inside the brackets. And I type 42. And now we define our population is np.random.normal. Normal is a normal distribution. Brackets, log is 170, that's your mean, comma, scale is 10, that's your standard deviation, comma, and size is 10,000. So, and then we're going to sample the population. Sample equals np.random.choice, brackets, population, comma, size equals 500, and comma, replace equals false. So that means every time they take a sample, they do not replace it. So now we're going to estimate the population parameters from the sample. Sample mean equals np.mean sample. That's the point estimate of the population mean. Sample variance equals np.var sample, comma, DDOF. DDOF is your degree of freedom, and that's your sample variance. It's an unbiased estimate. And sample proportion equals np.mean, brackets, sample greater than 175. And so that's the proportion of individuals with a height greater than 175. So now we're going to print the results of the estimated mean, estimated variance, and estimated proportion of people greater than 175 meters. So the estimated mean is 170, the estimated variance is 106.43, and the estimated proportion of a height greater than 175 is 30%. So now what we're going to do is we're going to plot the data onto a chart. So we have plt.figure, brackets, fig size equals 6,4. And now we're going to create a histogram of the sample. plt.hist, brackets, sample, comma, bins equals 20, comma, color equals light blue, comma, edge color equals black, comma, alpha equals 0.7, comma, density equals true, comma, label equals sample data. So now we're going to add vertical lines for the sample mean and thresholds for proportion calculation. So plt.axv line, bracket, sample mean, comma, color equals red, comma, line style equals dashed, comma, line width equals 1.5, comma, label equals sample mean. And then plt.axv line, brackets, 175, comma, color equals green, comma, line style equals dashed, comma, line width equals 1.5, comma, label equals height threshold 175 centimeters. So we're going to add titles and labels to the chart, and it's going to be this title is Sample Data Estimation of Population Parameters. X label is height in centimeters. Y label is density. You get a legend and you get a grid, and we're going to show the chart. So this is the sample data estimation of population parameters. So the light blue columns are your sample data. The sample mean is 170 centimeters, and the height threshold is 175 centimeters. So you can see that 30% of the samples were above 175, and this creates a normal distribution. So this completes the video for estimation of population parameters. The next video is going to be estimation with inferential statistics. So I hope that you will watch it.